Most people don't realize that simply going 24 hours without food begins changing how billions of immune cells behave. Not by instantly making your immune system stronger, not by magically curing disease, but by triggering a completely different biological program focused on efficiency, repair, and cellular maintenance. Not by making your immune system stronger overnight, not by magically curing disease, but by forcing one of the most sophisticated biological networks in your body to switch into an entirely different operating mode. Because when food stops coming in, your immune system doesn't simply sit idle waiting for your next meal. Hormones shift, inflammatory signals change, cellular cleanup pathways become more active, energy systems are reprogrammed, and some immune cells begin adapting to a completely different metabolic environment. The surprising part? We'll explore how immune cells respond to falling insulin levels, why inflammation changes, what role ketones play, how cellular recycling ramps up, and why scientists are increasingly fascinated by the connection between fasting and immune regulation. Let's dive into the science. Your immune system is one of the most energy-hungry systems in your body. Most people think of the immune system as a defense force, and it is, but it's also an enormous energy consumer. Every second of every day, billions of immune cells patrol your body. They're scanning for viruses, destroying damaged cells, monitoring tissues, repairing injuries, fighting infections, coordinating inflammation, building antibodies, maintaining surveillance. All of that requires fuel, a tremendous amount of fuel. Under normal circumstances, much of that energy comes directly or indirectly from nutrients entering your bloodstream after meals. But fasting changes that equation. And when energy availability changes, immune behavior changes too. The first 6 hours, business as usual. Immediately after your last meal, very little changes. Your digestive system is still processing food. Glucose is still entering the bloodstream. Insulin remains elevated. The liver continues managing incoming nutrients. From the immune system's perspective, everything is operating normally. Your body is still functioning in a fed state. Immune cells continue receiving signals that energy is abundant. No major fasting adaptations have begun yet. The real transition starts later. 6 to 12 hours. Insulin starts to fall. As digestion winds down, blood glucose gradually declines. In response, insulin levels begin dropping. This is one of the most important events of the entire fasting process. Most people know insulin as the blood sugar hormone, but insulin affects much more than glucose. Immune cells contain insulin receptors. They constantly monitor the body's nutritional status. When insulin remains high, the body operates in growth and storage mode. When insulin falls, cells receive a different message. Resources are becoming less abundant. Efficiency becomes more important. Maintenance begins taking priority over expansion. This shift affects tissues throughout the body, including the immune system. The inflammation switch begins to change. One of the most studied effects of fasting involves inflammation. Now, inflammation itself is not bad. Without inflammation, wounds wouldn't heal. Infections couldn't be controlled. Research suggests that fasting may influence inflammatory pathways through multiple mechanisms. Studies also suggest that fasting can reduce levels of several pro-inflammatory cytokines, chemical messengers such as IL-6 and TNF-alpha, that help coordinate inflammatory responses. Lower cytokine activity doesn't mean the immune system shuts down. Instead, it reflects a shift away from unnecessary chronic inflammation while preserving the body's ability to respond to genuine threats. This is one reason researchers are increasingly interested in fasting as a tool for improving immune regulation rather than simply boosting immune activity. As insulin falls and metabolic conditions change, several inflammatory signaling molecules may begin decreasing. At the same time, cellular stress response systems become more active. 12 to 18 hours. Your metabolism shifts gears. By this stage, liver glycogen stores are becoming increasingly depleted. The body begins relying more heavily on stored fat. Fat cells release fatty acids into the bloodstream. The liver starts processing those fatty acids for energy. This metabolic shift has important consequences because immune cells don't operate independently from metabolism. They respond directly to changes in fuel availability. Scientists now understand that metabolism and immunity are deeply connected. The arrival of ketones. Around this point, ketone production begins increasing. Ketones are fuel molecules produced by the liver when glucose availability declines. The most important ketone is beta-hydroxybutyrate. Most people think ketones are simply backup fuel, but that's only part of the story. Ketones also function as signaling molecules. They communicate information throughout the body. Research suggests that beta-hydroxybutyrate may influence inflammation, oxidative stress, and immune regulation. In other words, ketones don't just feed cells. The immune system enters conservation mode. As fasting continues, the body becomes increasingly strategic about energy allocation. Remember, survival has always been the primary objective of human biology. When food becomes temporarily unavailable, the body doesn't panic. It adapts. Resources are redirected toward essential functions. Energy expenditure becomes more selective. The immune system follows this same principle. Rather than operating in a constant growth-oriented state, it begins emphasizing maintenance and efficiency. This likely reflects millions of years of evolution. 16 to 24 hours. Autophagy becomes more active. This brings us to one of the most fascinating aspects of fasting biology: autophagy. The word literally means self-eating, but a better description would be cellular recycling. Inside every cell, damaged proteins accumulate. Old cellular components wear out. Mitochondria become dysfunctional. Waste products build up. Research led by Dr. Walter Longo at the University of Southern California has helped distinguish what happens during different fasting durations. During a 24-hour fast, the immune system primarily shifts into a maintenance mode. Falling insulin levels, rising ketones, and cellular stress signals increase autophagy, the process of identifying, breaking down, and recycling damaged proteins and worn-out cellular components inside immune cells. This improves cellular housekeeping and helps maintain healthy immune function. Longer fasts of approximately 72 hours appear to trigger a deeper level of immune renewal. In Longo's studies, prolonged fasting was associated with a reduction in older or damaged immune cells, followed by activation of hematopoietic stem cells, which generate new white blood cells during refeeding. In other words, 24-hour fasting primarily promotes cellular cleanup through autophagy, whereas fasting lasting around 72 hours may initiate stem cell-driven regeneration and rebuilding of parts of the immune system. Scientists continue studying exactly how these mechanisms translate to humans, but this distinction between short-term cleanup and longer-term renewal is one of the most important findings in fasting research. The gut-immune connection. Another important change occurs inside your digestive system. Most people don't realize that a large percentage of immune activity is associated with the gut. Your intestinal tract contains an enormous amount of immune tissue. This makes sense. The digestive system constantly encounters foreign substances from the outside world: food, bacteria, viruses, environmental compounds. The gut serves as one of the immune system's primary monitoring stations. During fasting, digestive activity decreases substantially. The gut receives a temporary break from processing incoming nutrients. While major microbiome changes typically require longer periods than a single 24-hour fast, researchers believe repeated fasting cycles may influence microbial populations over time. Why many people report feeling different. By the end of a 24-hour fast, many people notice changes. Some report improved focus, mental clarity, reduced bloating, stable energy, less hunger than expected. Others experience headaches, fatigue, irritability, difficulty concentrating. These responses vary widely. Factors such as sleep quality, metabolic health, stress levels, hydration, diet quality, and previous fasting experience all play major roles. What's important is understanding that beneath those subjective experiences, significant biological adjustments are occurring. What a 24-hour fast does not do. Now let's separate science from internet hype. A 24-hour fast does not instantly regenerate your immune system. It does not cure chronic disease. It does not make you immune to infections. It does not replace medical treatment. Biology rarely works that way. What fasting appears to do is shift the body's internal environment. It alters metabolic signals. It changes hormone levels. It influences inflammatory pathways. It activates cellular stress response systems. These changes are meaningful, but they are not magic. The benefits emerge from physiology, not miracles. Monthly 24-hour fasting protocol and refeeding. A simple way to use fasting safely is a single 24-hour fast, once per month, dinner to dinner. This is long enough to support metabolic switching and cellular cleanup processes, without the stress of prolonged fasting. Research from Dr. Walter Longo highlights that longer fasting windows may influence deeper regenerative pathways, but routine fasting should always be approached cautiously and not overused. Important, fasting is not suitable for everyone. Anyone with medical conditions, diabetes, or taking medication should consult a healthcare professional before attempting it. Conclusion. Your immune system is not a fixed defense force. It's a dynamic network that constantly adapts to the signals your body receives. During a 24-hour fast, those signals change dramatically. Insulin falls. Fat burning increases. Ketones appear. The question is whether you ever give it the opportunity. What's the longest fast you've ever completed? Let me know in the comments below. Subscribe, and if you want to go deeper on autophagy specifically, watch video 8 too.